Today we're going to review solving one and two-step equations, solving for an unknown value. Each operation has an opposite or inverse operation. If you recall, we talked about how the opposite operations are used to solve for a variable. The inverse of addition is subtraction. The inverse of subtraction is addition. These are opposite or inverse operations. Multiplication and division are also opposite or inverse operations. These four examples can be used to show how we can solve one-step equations. In the top two equations, x has a constant next to it. So to remove a constant, we use addition or subtraction. The first example has a plus 6 being added to x, so we use the opposite operation of subtraction. When we subtract 6 from both sides, the 6 on the left cancels out, and x equals 18. The second example shows that we're subtracting 5 from x, so we use the opposite operation of adding 5 to both sides. Again, the 5's cancel out on the left, and x equals 25. The bottom two examples show a coefficient next to the variable. The coefficient of x in the first example is 3. 3 times x equals 24. So we use the opposite operation of division to remove the coefficient. Divide both sides by 3, and x equals 8 because the 3's cancel out. On the last example, x is being divided by 7. The coefficient of 7 can be multiplied by 7 on both sides. Since x is being divided by 7, we multiply by 7. We use the opposite or inverse operation. Again, these 7's cancel out, so x equals 28. We can also have fractions as coefficients. In this equation, 2/3 x equals 24, we need to remove the fraction next to the variable. When we remove a number next to a variable, we divide by the number next to the variable. If we divide by 2/3, we're dividing by a fraction. Recall that when we divide by a fraction, that's the same thing as multiplying by the reciprocal. So we multiply by the reciprocal in this example. When we do this, the fractions cancel each other out so that x is isolated on the left. We can cross-reduce in this problem, and we are left with 12 times 3, so x equals 36. When there's a fraction next to a variable, multiply by the reciprocal. Dividing by the fraction is the same thing as multiplying by the reciprocal. This is a two-step equation. Notice that this two-step equation has a constant next to the variable as well as a coefficient. So we need to remove both numbers that are next to the variable. This is why it will take two steps. The first step will be to move the constant. We always move the constant first. Constants are moved with addition and subtraction. When we subtract 8 from both sides, we see that 4x equals 32. Next, we're going to remove the coefficient. 4 is being multiplied, so we're going to divide both sides by 4. That's the opposite operation. When we divide by 4, we get x equals 8. In this example, first we're going to move the constant, so we add 9 to both sides. X over 8 equals 5. Now we move the coefficient. We're going to multiply by 8. Because x is being divided by 8, we use the opposite operation of multiplication and multiply by 8 on both sides. So the 8's cancel out, and x equals 40. Here's a third example. Again, we're going to move the constant first. Since we're subtracting 3 from the variable term, we're going to add 3 to both sides. So we're left with, when the 3's cancel out, we're left with 3/5 x equals 12. When there's a fraction next to the variable, multiply by the reciprocal. We cross-reduce, and we're left with 60 divided by 3. 12 times 5 is 60 over 3. 60 divided by 3 is 20, so x equals 20. In summary, the goal in algebra is to solve for an unknown quantity. We isolate the variable to find a single value. To do this, we find the variable. We do the opposite. First, we're going to move the constant. We move a constant using addition or subtraction. Next, we move the coefficient. We move a coefficient using multiplication or division, and we solve for the variable. Hope this is helpful.